All right, now I want to attempt to explain why it should be possible that you can do something like this and assign a derived class object to a base class reference. Or in other words, why that can make sense and won't cause problems, but if we did it the other way around, it would. So this is what I was just starting to get to at the end of class last time, and got bogged down in the details and got my mind all mixed up as I was trying to explain them. But I think if I draw you one more picture, this will make sense why this is possible, but it wouldn't be possible to do it the other way around. So let's just say that I did something the other way. And I said rewards account Pete's account equals new checking account. Pete. Okay, so now we're doing the opposite. Now we're assigning the base class type object to the reference of the rewards account. Okay, so we'd end up with, again, somewhere in memory here, oh, maybe I could even draw it up above. Let's see if I can make this work. So we'd end up with something called Pete's account, which has the type of rewards account. That's the reference type. And that would go to some other place in memory. Let's kind of zoom out here a little bit. See if I can fit this all in. So somewhere else in memory over here, we'd have some slots available. Maybe this starts at 710, 711, 712, 713, etc. Okay, and we're going to end up with this referring to this object over here. But what type of object are we creating? We're creating just the base checking account. Okay, and so a checking account, as we saw, only has 3 variables. So a base checking account has an account ID, a balance, and an owner name. So we'd only end up with an object with 3 variables over here. So wherever it started at, we would have an account ID, a balance, and an owner name. Hopefully you can read up what I'm writing here, at least know what I'm talking about. So this would end up as that, the balance would be 0, and the owner name would be Pete. So that's our object right here. It's stored in memory. And I forgot to mention this again, but this whole area over here where we're actually storing the object's data is called the heap. And this reference variable now over here, it would be referring to that location right there. So it would say address 711. Okay, so here's the problem with that. And this is where you have to look at the details of what's actually being stored in memory for this type of object and what type of what type of methods are available to call on this type of object and how this might not make sense. So take a look at, if we look at a rewards account object like Pete's account, look at what methods we could call on that. So Pete's, if I wrote some code like this, Pete's account dot, what methods can I call? Well, let's look back at our rewards account class. Okay, so obviously I could call all of these that are inherited by that class. So get, balance, deposit, withdraw, those would be fine. But I can also call things like charge monthly fee, that changes the monthly fee or uses the monthly fee, or something like reset points. So on a rewards account type of variable, I have the option of calling reset points. That's one of the methods in the rewards account class. So let's look back at what that would do if I said reset points. Okay, so if I tried to call reset points on this object, Pete's account, which I could do because reset points is one of the methods available in this class, how would that make any sense? Or in other words, what problem would that cause if the actual object that's being stored for Pete's account is sitting over here and it doesn't have a number of points? Because that particular object is a checking account object. There are no points in a checking account, or basic checking account. And so reset points is going to try to go over here and access some variable for points and it's going to find that it doesn't exist, and it's going to basically cause a problem. Or we could look at our other one, like our charge monthly fee, that accesses the monthly fee variable that's stored in that class. So if I wrote Pete's account charge monthly fee, it would try to go over here, get the monthly fee, and deduct that from the balance. Well, there is no monthly fee. So it makes no sense to allow this type of class that has more variables in it and more methods in it to try to call methods on this type of object that has less data to actually, it doesn't even have the data for some of those methods, right? It doesn't have the data available for some of those methods. So that's why it doesn't make any sense to be able to do things this way. And this is what I was trying to get at the very end of class, is that this wouldn't make sense, and having a picture like this, I hope, makes that clear, because this object doesn't have the data for this type of reference variable to be able to call all of its methods. But if we look at the other way around, where we have the checking account class with the rewards account object, so back to our very first example, okay, the object over here has more pieces of data, okay, has even extra data, it has all the data, and the methods over here then the methods over here that can be called in a checking account class need to access. So in other words, if we look at Ed's account, ACCT, which is a checking account type of reference, if we look at that and we look at what methods can be called on it, we're limited. Okay, we can't call the getPoints method. We can't call some of the other methods. We can only call the methods in the base checking account class, because that's what type of reference variable this is. So if I come back here and look at this, go back to checking account, I only have these methods available, and all of these methods only access those three variables. So they access balance and owner name and account ID. So we have less methods that only, and these methods only access these three base variables. So in this case, we have absolutely no problem. Any of those methods that we could call on this type of class, such as getBalance, okay, any of them that we can call, the variables, the associated variables, are going to be over here, because as a matter of fact, not only do we have those three variables right here, owner name, balance, and account ID, we even have some extra stuff that we can't even access from this particular type of reference variable. So we're covered. We've got all the data we need. We would only need these three variables for any of the methods that can be called on this type of object over here. Okay, so again, getBalance needs to access balance, or printAccountInfo just needs to access basically these three variables. So we have no problem doing it this way, where we're actually assigning the type of object that has extra data to the type of class reference, the reference variable that actually only accesses fewer pieces of the data, or its methods only access fewer pieces of data. So you can see that this is a little bit complicated, and that is true, but it's something that's, unfortunately, these are the types of details I wish we didn't have to go into, but in order to make sense about what you do with these type of objects when we get into things like having array lists of multiple types of objects, you really have to understand some of these details to make sense of that. And that's what we're going to get into next.